there! In this video we're going to continue talking about arrays, and we're going to look at a couple of traversal examples where we do some numerical operations. We're going to get a set of numbers, and then we're going to find the minimal value, the average value, and the maximal value. So our first task is going to be getting information into our array that isn't predetermined. We've seen how we can initialize everything to a single value, and we've seen how we can initialize everything to predetermined values using the initialization shortcut. But now we're going to ask the user to provide the information either with the keyboard or through a file. We're going to plan to work with some numbers, basic integers. We're going to say that there's a maximum of 10 of them. And we're going to ask the user to provide this information first so we can see what it looks like. We're going to have to ask them for all 10 pieces of information, which means we need a loop that runs 10 times. So we're going to set up our for loop so that it will have 10 iterations. And we're going to ask them for each iteration to enter a number. Then we're going to read in that value, and this time we're working with integers. So we're going to read in an integer, and we want to place it in the current element of the array. So when I is equal to 0, they'll enter their first number. We want to put it in the first element of the array, which is indexed by 0. So for the ith iteration, we want them to enter a number and put that in the ith element of the array. So starting at 0, then 1, then 2, all the way up to 9. Then just to make sure that the information is stored in our array, we're going to do a double check where we just print out the values. And this will look just like the example we did in our previous video, where we print out the index and the value just to make sure that everything is working correctly inside the program. Okay, so it's going to ask us for some numbers that the user will have to give them. So we'll just make up some numbers. It's going to ask us 10 times. And after we've entered all 10 numbers, then it kind of prints them back out for us to see what they look like. And of course, that's not a very interesting process, and that's one of the reasons we deal with file input, is so that the user doesn't have to sit here and type in each individual number for the whole array. We could instead get that information from a file. So that's what we're going to do next. I have this file of randomly generated numbers. Has 10 numbers in it, and it's set up so that the first thing at the top of the file is how many numbers there are going to be. This would help us control the length of valid numbers if our array happened to be bigger than 10. So here's our file. It's called numbers.txt. So we're going to add that to our program, create an input file pointer that opens numbers.txt in read mode. And instead of asking the user for a number and scanning it in, we're instead going to read from the input file pointer the next integer and put that in the ith spot of the array. We'll also need to read in that first header value, which tells us there are 10 numbers in the array. And then we'll leave this print statement for right now so that we can double check to make sure that when we run the program the numbers that we have in our array in the program are the same numbers that we have in our input file. So we can compare them one to one and see that everything in the array is the same as what we've got in our input file. So now we're ready to start doing some processing on our information. We're going to be calculating the minimal value, the maximal value, and the average. So we're going to create some additional variables that we'll need to figure all of that out. First, let's calculate the average. To calculate the average, we want to traverse the array, add up all of the values, and then divide them by the total number of values, which we know is 10. So we're going to use our accumulator sum to accumulate all the values in the array. Then we'll traverse the array, visiting each index and adding that element, the value at that index, to our sum. So for each element, we'll go to our array at that index, and we'll add that value to sum. And once we have the sum of all of the values, then the average will be sum divided by the total number of values, which we have stored in header. But sum and header are both integers, so we have to be careful that we're not doing integer division in this case. We can cast either of them to be a float, or since we know we're only working with 10 values, we could do sum divided by 10, where 10 is a float literal or a double literal and not an integer literal. So either of those is fine. And once we've calculated it, we're going to print that out for the user. So that we can see it. So we'll check it and see what it looks like. We're going to see that the average of these values is 25.8, which is something that we can easily double check with a calculator. Now suppose that we wanted to find the minimal value, or the smallest value in this set of numbers. That's something that we as humans do very easily. It doesn't take us long to glance at this list and go, oh, 2 is the smallest. It's a little bit more complex when we have to explain the steps that we follow to a computer. So what we're going to do is we're going to pick a value from our set and compare it to all other values. And anytime we find a value that's smaller, we're going to take that one and compare it to all other values. So that when we're done, we should be able to say this is our smallest number. So we're going to start with 16, and we're going to say 16 is the smallest number we've seen so far. And then we'll go through and we'll say it's still smaller than this one, smaller than this one, smaller than all of these, until we get here. And now this is the smallest number we've seen so far. So we'll take 2 and say, well, is it smaller than everything? And since it's smaller than all the other values, 2 is the smallest. So then we just have to translate those steps into code statements so that we're doing the same thing here. So min is going to start as the first value of our array, and then we'll compare it to all other values. So this traversal actually looks slightly different. Instead of starting at 0, we're going to start at 1 because we've already got the first value of the array, so we can skip over that one. And then we're going to compare all of the other numbers to the minimal value. And if we find one that's smaller, then we're going to update our minimal value. Because if we find that one that was smaller, then obviously it wasn't the smallest. And then we're going to print that out, and that will allow us to double check that we are calculating the minimal value correctly. So now when we run it, we see 2 statements. We've got the average of the values, and the smallest value is 2. we're going to follow largely the same process for the maximal value. Just instead of looking for the smallest number, we're going to be looking for the biggest number. So we're going to still start max at the first value and compare it to all other values in the array. And the only thing that's different is if the number we're looking at is bigger than our maximal value, then our max value must not be the biggest yet, and we should update max. So we'll traverse the array, we'll go from beginning to end, and keep the one that is the largest. We'll go ahead and run this one, make sure that it's working. We can see all of the values, see the average, the smallest one, and now the largest one, and we can easily look through the list and say, yes, it's picked out the biggest one. The biggest one is 46. So now that you've seen several examples of traversing an array, it's your turn. Try to add on to this code so that the user can search for a specific value. Say they're looking for a certain number, like 14. Write a loop that will traverse the array and identify whether or not 16 or 14 or whatever the user enters is in the array or not. Pause the video while you work on this example and then come back and see my solution. Okay, there's a few things that we'll need to add to our code. We of course need the value that they're searching for, and we need something to indicate whether or not we found it. So search is going to be an integer that the user provides, and found is going to be a flag for true or false. It currently says we have not found it. So we'll start it at 0. The user will give us the value that they are searching for, and we're going to traverse the array and see if that value is present. So we're going to take their value and compare it to each element of the array. And if at any point the value in the array matches their search value, then their value is in the array. And if their value was in the array, then we can print out their value was there, the value they were searching for. And if it wasn't, we can give them that information as well. And let them know whether they were right or wrong. So let's do two different test cases, one where we search for a number that is in a set and one where we search for a number that's not in the set, so we can make sure that both of these print statements work correctly. Okay, so let's start by looking for a value that we know is there. Our search code's correctly identifying that that value is here. We look for something that's not there. It can also identify that that number is not present. So now we can search for a specific value. In our next video, we'll examine some common errors that people make with arrays, and I will see you then.